energy, but it's not something we've been able to use. Chemical cells and batteries produce direct current, DC. We have some types of batteries that are not rechargeable. Here you see some alkaline batteries, very common type of battery that you use in electrical devices, flashlights, radios, and other toys and things like that. Batteries come in all different shapes and sizes. There's some rather not so common ones here that have different voltages and shapes. Some batteries are rechargeable, such as these NiCad batteries, like you might find in a rechargeable phone or shaver, toys, tools. Chemical cells use two different metals immersed in an electrolyte, which is either an acid or a base. The acid or base reacts with the metals. Now, because the two metals are different, the reactive, during the transfer, there's movement of ions. Well, if you remember, ions are electrically charged atoms. And because the metals are different, there's a different amount of charge transfer occurring between the two metals, and that creates a voltage difference or potential difference, which is the basis of pushing an electric charge through a wire. The electrolyte will continue to operate on the metals and dissolve one of the metals, maybe at a different rate than the other, or deposit one of the metals on as like a plating action if it's run in reverse, and this will continue until the electrolyte or the metal plates are used up. Now, the metal plates being different, then one will have a positive charge with respect to the other one. The one with a positive charge in a battery is called the cathode, and the anode is the negatively charged one. Now, you may remember from us mentioning before the diode that they had two parts of the diode, like an LED. A diode has an anode and cathode, and on the diode, the cathode is the negative side and the anode is the positive side. Now, you may say, well, that's rather confusing, but this is because this is a source of electricity, and so it's operating in reverse polarity, in reverse direction. So in a battery, it's the opposite. Now, you can make electricity from anything with acid or base in it. A lemon works great. Putting a piece of zinc and copper in a lemon, you can make a little battery. In fact, you can connect them in series to get different voltages. We see several lemons connected up, and you get about 3.5 volts. One of the more common types of batteries is the carbon battery. It consists of zinc, a metal plate on the outside of the battery, and a carbon terminal in the inside. Now, the carbon is not consumed in the battery. The zinc is consumed. And the carbon battery, the carbon is the positive terminal, the carbon rod, and the zinc is the negative terminal. The zinc is what's consumed. So if you leave one of these batteries sitting around a long time, eventually the zinc is going to be eaten up, and they even will develop a leak. These don't have a particularly long shelf life, but they do produce a good deal of energy, and they're the least expensive type of battery, throwaway type battery. A more expensive type of battery, but has one with a much longer shelf life and a greater amount of energy stored in it, is the alkaline battery. It doesn't have a carbon rod. It has a metal pin in the middle of it. It has a paste also, but it's a little different construction, such that this type of battery does not leak as fast, and so has a longer shelf life. You can leave it on the shelf for a few years and still have a fairly large amount of the charge remaining. Lithium batteries are one of the most dense or most energy containing batteries that we have today. The lithium battery, for its weight, has the greatest amount of energy. These are used in watches, cameras, and other devices. There's also rechargeable versions of the lithium batteries. Lead-acid battery is what we use in our cars. Lead-acid batteries have two types of metal plates. One is lead and the other one is lead dioxide, which is kind of like rusty lead. The two metal plates respond differently to the chemical electrolyte, which is sulfuric acid, and therefore produce a difference of charge. A typical car battery has 6 of these cells, or 6 pairs of plates, and each one produces around 2 volts, so that gives you 12 volts. As the acid in the car battery reacts to the metal plates, it deposits sulfur. There's ions of sulfur and hydrogen in the electrolyte, and these are charged. The hydrogen ions are positively charged, and the SO4 ions are negatively charged. The plates become coated, and as the battery becomes discharged, they become more and more coated. Now, as you reverse the polarity, put the current back into the battery, you can recharge it and reverse the process and take the coating off of the one plate and transfer it to the other, and so reversing the process and recharging the battery. This type of battery does have the ability to be charged and discharged many times. Eventually, though, it does wear out, and then the battery can be recycled. It can be taken apart, the electrolyte replaced, of course, and the plates either refurbished or melted down and recycled. When a lead-acid battery changes its charge state, the electrolyte density changes. So it's possible to measure the charge state of a lead-acid battery by simply determining the specific gravity or the density of the liquid in the battery. You can suck some of the electrolyte out with a tool called a hydrometer, which is a little float floating in the sulfuric acid electrolyte, and the float level determines the charge state of the battery. Another type of rechargeable battery is the nickel-cadmium battery. Nickel-cadmium or NiCad batteries are a very common type of rechargeable battery used in things like power tools and electric toys, rechargeable appliances, electric shavers. These batteries can deliver high currents and can be recharged many times. They like to be charged fully and then discharged fully in a cycle. They last longer if you do that. They don't like to be charged just a little bit and then discharged a little bit, which is kind of the opposite of the car battery. Car batteries like to stay charged if possible, and they don't like to be discharged very deeply. So they're sort of opposites of each other in that regard. This is the schematic symbols for a battery. On the left we have a single cell symbol. Notice that the longer line is the positive side of the battery and the shorter line is the negative plate of the battery. The lines represent the metal plates. A multiple symbol on the right indicates more than one set of plates, or a battery. A battery is actually technically the term referring